this is my presentation for an introduction to statistics. So these are the topics that you actually cover in statistics. You'll see a long list of ideas there. You'll start out with population, samples, and sampling, because there's something you want to study, so you have to identify your population, what it is that you want to study. And then you have to think about, well, how many of that population do I need to test? So there's a process of sampling the population to get at least some information about that population. So if you wanted to research, say, everybody in your country, you can't research everybody in your country. You have to take a population, a sample of that population, and then you have to infer from that sample population information about everybody. So that's basically how statistics is going to work. You take a sample and then you infer from that sample information about everybody. And so there's a process that you go through in that sampling of a population to verify and confirm what you can know about everybody. So once you have your population and you're ready to start sampling, you go into collecting that data, surveys, questionnaires, experimental tests, whatever. If you're doing plants and you're growing plants and you want to see how different fertilizers affect different plants, you have data where you're weighing the plants, or you're seeing how tall the plants grow, or you're seeing how many flowers they produce, or you're seeing how much the weight of the seed that they produce. So there's all that data that you're collecting from the plants that you're growing using different types of fertilizers. And so you're getting data, and then that data, once you have that data, you can analyze it, draw conclusions. Once you have your conclusions, you can write a paper on it and publish it. It's just that simple. And as I go through this course, you'll see these on the webinar list. As you go through these courses, you learn how to do the tests, how to do the sampling, how to write up your results so that you can publish your papers for your research. So as we go through, there's different types of statistical studies. There's descriptive statistics, where you're not using quantitative analysis. You're not really using numbers. You're using generalities, thoughts, concepts, that you're describing trends. But when you actually have numerical data, then you can actually use quantitative. So as you go through here, these are all the things that you learn to study in statistics. And one thing I want to say is that you want to keep statistics simple. It does not have to be complicated. Of course, there are very advanced statistics that are very complicated, but truly and seriously, the basic statistics are perfect. They're fine. They give you plenty of good information. You don't have to be a professional statistician to write up research papers. You can use basic, simple statistics and present your findings. So keep that in mind, that statistics is actually very easy. Within just a day, you can learn what you need to learn about statistics, learn how to write up the results on that, and publish it. You don't need years of studying complex statistics. You just basically, once you have a research experiment that you want to do, there's this process of determining which type of analysis you're going to want to do. And there's a great video on YouTube that explains it much better than I could. So I would have you watch that video. But let's go ahead and start into this world of statistics. Now, in the library of AIU, here's some books that you will find there. And you'll see the link up above. If you want to, you can take a picture of this slide. And so you'll have that link. And then once you get into the library, you just search for the word statistics and you'll see lots of books. We have business statistics, Bayesian statistics, all kinds of statistics. And then, but you'll also see these books in there. And these are the books I recommend for people who are just getting into statistics. Let's see, one of my favorites is that one on the left, where it says Reading Statistics and Research. I like that book because it actually shows you how to write up your results. It gives you examples of how to write them up. And it also uses G-Power. You'll see that I use G-Power, and since I've been teaching statistics, many students have used G-Power to present their results, and it just makes it so much easier to show what your numbers mean. So look for that book on the left there, Reading Statistics and Research. All right, let's continue on. So here's some great YouTube channels. Joshua Manuel, Dr. Todd Grande. You'll see, you can take a picture of this and you'll be able to go to those YouTube channels and look at some very good introduction to statistics types videos. I'll give you a couple of seconds. It's actually very hard to find really good videos on YouTube for statistics. So I recommend that many of you, if you want to present statistics and teach statistics on YouTube, go ahead and do it, because we always need better YouTube videos. And if you want to show statistics for the type of work that you're doing, show some videos, give some examples on that. And people will find you. So the statistics software that would be used for this series that I teach on statistics is Excel. Everybody has Excel. Pretty much everybody has Excel. And there's some add-ins that you're going to want to put into Excel. Your data analysis tool, solver, and real statistics. Now, these are all free. I want to keep it simple. I want to keep statistics simple because it does not need to be difficult. So the Excel add-ins must be installed into Excel for them to work. So to install data analysis tool and solver, you can see the instructions there. You can take a picture of this presentation. I could probably also, a little bit later, download this presentation into chat, and then you can just download it from chat. But right now I can't get into chat unless I can. Yeah, maybe I can. Yeah, looks like I can get into chat. So I'm going to put the presentation there so that you can have it in your computer. Give me 1 second to find it. I have 18 courses, 18 presentations on statistics. This is the very first one. This is number 1. So give it a second. There. So you'll be able to download this presentation from chat right now. Okay, so for those of you that want to get more advanced in statistics, but you still want to keep it free with no cost, you want to install Real Statistics. So there's the link, realstatistics.com/free download. So then you go to the Real Statistics resource pack and the Real Statistics examples workbooks, and you'll see the instructions to install. And they're really good there on that site about asking questions. The professor that's there giving that Real Statistics package is really good. He's an expert in statistics. And anything you want to know about statistics is there. He's developing it in that program. But he keeps it also very simple, but there's also functionality in that resource pack that is very advanced. And it's all free. And so you have one professor giving a great add-in to Excel. And that's really all you need, this Real Statistics resource pack that you download into your Excel It's all you need to do analysis, to do statistical analysis. It does not have to be complicated. Statistics is easy, really. So what is research? So basically, you're asking questions and gathering data to try and answer those questions. That's what research is. Something you don't know or something nobody knows, and you're trying to get an idea of what the information is. You know, what's the truth about something? You know, if you're doing fertilizer on plants, and this is a different type of fertilizer that no one's really ever used before, so nobody really knows how this fertilizer is going to affect plants or a certain type of crop, or like a bean or a flower or a fruit. So nobody knows yet how this fertilizer is going to affect certain production of food. So you ask the question, how will this fertilizer affect a certain fruit production? So you set up an experiment, you gather the data, you do an analysis, you present your results, you have the first paper about this fertilizer. And people will go to read your paper to find out what you did, how you did it, and what your findings were. They want to know your results, because they want to go back and maybe do another experiment based on your experiment to understand a little bit more. So what is statistics then? Well, you're going to gather data, collect that data, organize it, analyze it, interpret it, and then present the results. So statistics seeks to ascertain the truth without knowing directly and precisely what the truth is. But you're gonna get close to what that truth is. So we gain confidence through statistics that we can know the truth. It is essential that statistics is done in a proper way. So as we go through this, you'll see how statistics actually verifies its own information by having levels of confidence, that you're confident that the results are good, that we can have confidence in the results. And then statistics will also tell you, we really don't have confidence in these results. And it gives you certain numbers that you can base that on. So once you see the number, you'll see there's a confidence level. And if you can reach that confidence level, okay, you have confidence in the results. If you don't reach that confidence level with the results you have, you can't be confident in those results. And so statistics has this sort of built-in quality control to the data and the analysis that you're doing. So whatever you produce from your statistics, it's built into statistics to say, okay, this is quality or this is not quality. The results are good, or we really don't know if these results are good or not. And so statistics has this built-in quality control, and it's simple. Once you run the data through these programs like Excel, the numbers that kick out will tell you automatically whether you can have confidence in those numbers. It's not some big equation that you have to use. The software gives you the numbers automatically. And then you just have to look at the number and you'll know right away whether you can have confidence and what type of confidence you can have in your results. Okay, so let's look at the uses of statistics. There's many types of questions we can ask. Every single major that we have at AIU has questions that they can ask about something. If you're in education, you can ask about certain types of tests, certain types of activities to teach students mathematics, for example. Or you could have another major of accounting, and you're doing statistics on certain types of trends and certain types of benefits from costs and income, cost production. If you're in engineering, statistics is a big part of engineering and sciences, to where you want to know the strength of new materials. You want to know how long certain things last. You want to know if you have a new paint, you want to do some experiments to show how long that paint will last on certain types of surfaces. So this just goes on. You can see a list here. Like a public official may want to know if citizens prefer one policy to another. So they do a survey of the population. Would you prefer this policy or this policy? And so they can judge from the results what everybody in the country would want. So they sample a certain population in the country, and from that sample, they can infer, what is most popular, what would be the most popular policy. A nutritionist may want to know how well clients are benefiting from a new diet. So the nutritionist puts their clients on a new diet and then maybe monitors weight or monitors blood pressure or monitors work productivity, whatever, or sleep patterns, right? So you want to see how different types of diet maybe affect sleep patterns or work productivity or whatever. There's all these questions that are just anybody could ask about anything. And so statistics really helps you start developing ideas that you want to research. And if you're doing a thesis paper and all of a sudden you realize, wow, no one has really done research or statistics about this one particular thing that I'm interested in. Well, through statistics, through what I teach, you can actually develop very quickly a survey or a questionnaire or get some data. And then very quickly, within minutes, you can have the results of your statistics within minutes. You just put your data into Excel, push a few buttons, and you automatically get the results. All the numbers, everything. It's learning how to read those numbers is what statistics is all about. But actually getting the numbers is very, very easy and fast. Within minutes, you could spend 3 months getting numbers, and then within a few minutes, you put them into Excel, push a few buttons, and get your statistical results within minutes. It'll take you 3 months to do the experiment, and within 5 minutes, you have the results. That's the power of softwares. Okay, so here's some preliminary ideas about research. So do not worry about statistics. Think about the issue that you are researching. And then you'll have to want to apply the statistics that are appropriate for the type of research that you're doing. So just don't worry about statistics. Just what do you want to research? And then you'll find the right statistical analysis for what you want to research. So think about what you want to research, determine a question, and then think about what data you would collect to answer that question. And once you know what data to gather, you will know what type of statistics you need to analyze. So remember to always think about the issue you are studying and the question you want to answer. Let the statistics be a tool, not the goal. For example, if you want to carve wood to make a bird, use the tool that allows you to carve the bird. You could use other tools that really aren't great for carving the soft curves of a bird. So if you want to carve a bird, you use a tool that's going to give you those soft curves. And that's what statistics. You want to use a statistics that's going to allow you to make, those smooth curves carving the bird. But if you just want to carve out a block and you need just a saw to cut the wood, okay, if that's what you want, just use a tool to cut sides and you're done. Statistics can do that too. If you just want to do very straightforward, fast, you can cut, you got it. So finally, if the results of the statistical analysis differ from what you expected, trust the statistics. A professional trusts the statistics. They are answering your question. And you'll find many, through my own studies of reading papers, it's always interesting when I find a paper written by a professional, by one of the top scholars, where they developed a couple of equations, did the analysis, got the results, and then when they look at the results, all of a sudden they say, I am amazed. I did not expect these results from the statistics. I thought they were going to be different. And so, and then they say, but the statistics said otherwise. So these high scholars who do research, they said, I'm going to go with the statistics because the statistics does not lie. The statistics is based on fact, on the numbers. And I was trying to think it through, but the statistics actually told me, no, this is the way it is. So learn to trust your statistics. Now, once you have everything ready and you have your results, then you report your analysis of the statistics. You can include statistics in your AIU essay papers. And you'll think, oh, I don't want to do a long research study and do statistical analysis. It takes you less time to do statistics for your paper than it does to write one chapter. Once you have the numbers and you do an analysis, it could take you just about an hour sometimes. And then to write it up, when in the series of courses on statistics, I show you how to write up your results. And once you know how to write it up, it can take you another 20 minutes. So within an hour or two, you've finished a statistical analysis for your essay paper for AIU. And this is one thing I wanted to teach, is that at any level, from high school to the college, university, to the doctorate programs, you can use statistics very easily and very quickly to get information to present your research ideas. So statistics should be taught in high school. In my opinion, statistics should be taught in high school instead of calculus. Statistics is much more practical, much easier to learn, much easier to use than calculus. So keep that in mind, that statistics is easy. Calculus is more advanced, really. It's really a university type mathematical tool. Statistics is for anybody. Even somebody who's 5 years old could use statistics. But maybe they'd have to have a really good reason to use it. So, okay, let's move on. So here's a sample of how to use statistics. So first, the duration of a human pregnancy follows a normal distribution with a mean, which is like an average, of 274.5 days. So that's how long a human pregnancy will last. 274.5 days with a standard deviation of 13.6 days. Okay, so you probably understand 274.5 days as the average length of a human pregnancy, but you might be thinking, what's a standard deviation of 13.6 days? Well, what does that mean? So with that information, you think, okay, so what is the probability that a human pregnancy will last at least 270 days, right? So you're given that information of the average length of a human pregnancy, and then you're given that standard deviation. The standard deviation is basically going to give you an idea of how variable that data is around that average. So if you have a really large standard deviation, that means you could have normal pregnancies going from maybe 230 to 350 days of a pregnancy. If you have a large standard deviation, let's say that standard deviation was very small, maybe 2. Well, then most pregnancies are probably within 272 and 276 days. That's very precise. But as it turns out, the standard deviation is about 13 days less or 13 days more than 274 days. So that gives you an idea of how variable the length of a pregnancy is. 13 days less or 13 days more. Most pregnancies are going to fall within 260 to 287 days. Most pregnancies are going to be within 260 to 287. So there's a 27-day period within which most pregnancies last, and that the baby is born. So then what is the probability that a human pregnancy will last at least 270 days? Okay, so you see where this question is going. You want to figure out the probability, which is part of statistics. So, okay, so we need the population mean, 274.5. Then we need the standard deviation, which is 13.6. Now, the probability for all pregnancies longer than 270 days. So we're going to use Excel. The function in Excel is equals norm dot dist, which is the normal distribution. So we're looking at a normal distribution. It's going to say 270 is the limit. So we want to know 270. Then we give it the 274.5, the average, and the standard deviation, 13.6. And then we say true, which is going to give us the higher the amount of 270. So this function gives the probability of pregnancies to the left of 270 in the diagram. So you'll see in this diagram to the left where it says 37%. So the result is going to be 37%. To get the probability to the right, we just subtract 37% from 1, like 100%. So 100% minus 37% is going to give us 63%. So as you can see in Excel, just take out your Excel program, type in this down here, you'll see that function equals norm.dist, which is normal distribution, parentheses 270, comma 274.5, comma 13.6, comma true, parentheses. Just type that in, and it'll give you the probability to the left on this distribution. So you'll see this curve here. I don't know if you can see my mouse. Can I draw? Let me see if I can draw on here. Yeah. So this curve right here, that's a normal distribution of data. So that data is normally distributed. So you can use this normal distribution of data to figure out certain percentages. Let me see if I can erase. There. So this is looking at statistics. This particular sample here has shown that the probability to have a pregnancy of at least 270 days is 63%. So from this simple equation, you can write the probability of having a pregnancy longer than 270 days is 63%. 37% of the pregnancies the baby will be born in less than 270 days, in 37% of the pregnancies. Now, you start to think about this probability, and you might think, okay, pregnancies is pretty well understood, but you may find something in your own research where you don't know the probabilities of certain things. And so you're going to do an experiment. You're going to get an average you're going to get your data distributed in this normal distribution, a bell curve, right? You're going to get it in that bell curve. So you're going to have a normal distribution of your data. Sometimes you don't have a normal distribution of data. We talk about that later on in this series on statistics. But once you have your normal distribution of data, you get your population mean, which is the average. And then from that distribution, from that data, you put that data in, just put all your data into Excel, and then all of a sudden you can do a function for the average, and you can do a function for the standard deviation, and you can get those two numbers very quickly. And once you have those two numbers, then you understand where your bell curve sits on that x-axis. And then you want to start doing probabilities. You know, what's the probability of something in the data that you're researching? Let's say you're doing fertilizer on fruit trees. And then you get this data that's distributed at the end of the weight of that fruit produced from that fertilizer versus data of fruit trees that are producing fruit without that fertilizer. So then you get your data, though, on the fruit that's being produced. And you can think, what is the probability of this fruit weighing more than the average mean of the fruit without fertilizer, right? So you look at your fruit without fertilizer, and you get that average weight of the fruit that's produced. And then you fertilize, and you want to know what is the probability that this fertilizer is going to produce fruit that weighs more than without fertilizer. So let's say if you have that average mean without fertilizer, everything weighing more than that mean is 50%. That's basically what it says. The average is going to be basically 50% of that fruit is going to weigh more than the average. But let's say you put on some fertilizer, some special fertilizer, and all of a sudden it comes back and says 80% of the fruit that you produce will now weigh more than the average from before. And that's a nice thing to present in your paper. With this fertilizer, 80% of the fruit produced weighs more than the average without the fertilizer. So you've increased your probability of growing more fruit, more weight. And if you sell your food production by weight, you just increased your profits. And then you can understand how much more money you can gain by selling your seed production or your fruit production by weight. And then you think, okay, how much more money will you make because you're producing more weight? Well, how much more money does that pay for this fertilizer? If the fertilizer costs 20% of the profits, you want to use that fertilizer because spending that money for the fertilizer is going to pay off 5 times more in profits. So there's certain ways of looking at the numbers to say, okay, if this fertilizer is going to make let's just put it into round numbers, 100 more money, but it's only going to cost us 20, then for that 20 of whatever currency you're using, 20, the cost is 20, it's going to produce 100 extra in profit. So these are the types of statistics that help you as a business manager decide what's going to make you the most money. So you're going to want to do if you're in agriculture and you want to find out, or in business or in science, anything, and you want to figure out if you want to make a change of fertilizer, or you want to change the price of your product, or you want to change a certain material that you're using to produce your product, you can use statistics to find out if it's going to make you more money, how much it's going to cost you, but is it going to make you more money than it costs? And that's when statistics starts to make you money. And seriously, that's really where you want to go. That's where you want to be with statistics, using it to make you money. Okay, so we looked at this duration of a human pregnancy following a standard deviation, or following this normal distribution. So we write our essay. Thus, the probability that a human pregnancy will last at least 270 days is about 63%. That's all you need to say. That's all you need to write into your essay. As far as presenting the results of your data, but now you're going to interpret that. Now it falls upon you to explain that. So once the statistics gives you the number, now you explain it in your essay. Now that we know that 63% of all pregnancies will last at least 270 days, we can now think about this issue in this way. So once you have that very fast statistical data to put into your essay, it can then help you develop your recommendations for what you want to do, or it can help develop your results. Or you can say, okay, now that we know that this fertilizer is going to produce so much more weight with this much cost, now we can figure out how much more money we're going to make with that extra weight of food production. And so just with that simple experiment, you can say, okay, so we write in our essay, thus, the probability of producing food with a higher weight than the average without fertilizer is 80%. Now, if we look at this, then you go on to analyze it and interpret that. Say, now, if we look at this, that means we're going to make so much more money. With a cost of 20 for the fertilizer, it's going to produce 100 more in profit. So therefore, this fertilizer is going to pay for itself 5 times over. Whatever we spend on it for 20, it's going to produce 100. And then that's your result. That's your recommendation. So then at the end of your essay, you're saying, because this fertilizer makes more money at a lower cost, I recommend everybody start using it. And I'm selling it. You can buy it off of my website. Here's my fertilizer. I'll send it to you, package it up. Here's the cost. And so you use your research data to show your clients that your fertilizer will make them money. And they'll come in and start buying the fertilizer from you because you've shown statistical research on how well it does. So you see where this is going. It's very easy. Get your data. Within a couple of paragraphs, you write it up. And then you put that on your website, selling your product. You start making money. You can do this for a business. You can do it for your own business. Okay, let me check to see what time it is. So that okay, got about 15 more minutes. So I want to get you an idea here that statistics is very easy and you can use it very quickly. Let's see, I've got a question here in chat. This is Dr. Masao Sufiri Motolo. In mathematical theory, the binomial distribution can be approximated by the Poisson distribution to roughly get the same answer. In the case of some doubt in the independence of events observed, can the answer given by the Poisson distribution be more accurate? See, think about this. We're looking at different ways of doing statistics. We're looking at the Poisson distribution now. We're looking at the binomial distribution. These are things that you're going to study as you go through statistics. But what I want to get across to you right now is it does not have to be complicated. You don't have to be even more accurate. Sometimes if you're just going to sell fertilizer, you just need a simple experiment with some simple results that your clients are going to understand because they're farmers. A lot of them don't understand statistics at all. So if you come to them and say, look, I did a Poisson distribution with a binomial distribution to find out which was more accurate here, they're not going to understand what you're doing. They just need it in simple terms. Is this fertilizer going to make me money? And you say, yes, according to my statistics, if you pay 20 whatever for this fertilizer, you're going to make 100. And they're not going to ask you what type of distribution did you use. You're basically just gonna say, I did a normal distribution test to find out, to figure out the extra weight added by this fertilizer. So all I did was I was able to calculate the extra weight that was produced by this fertilizer, and the extra weight is going to make you 100 extra in income, and it's only going to cost you 20 to get there. And so you keep your message very simple. Now, if your public, if your clients are other scholars around the world, then you're going to want to bring in Poisson distribution, binomial distributions. You're going to want to bring in those independent events. You're going to want to bring in the high-level statistics, because now you're dealing with people around the world who are trained in high-level statistics. But what I want to get across to you is that if your clients don't really understand statistics, keep it simple. Keep it simple. If you want to go on the news, and at night, and sometimes they'll say in the news, 60% of the public are in favor of this, and 40% are not in favor of this. That makes it very clear to understand 60% of the population is in favor of this. So that's very simple to understand. Now, to get to that same question of like how many people are in favor of this, you could make that statistical analysis very complex if you wanted to, where you could come out and say, well, according to the statistical analysis, certain people within certain groups within certain distributions, and it's not really a normal distribution, it's like not an abnormal distribution, but we were able to do some of the statistics to figure out some of the, if you start explaining advanced statistics like that, people are not going to understand what you're going to say. So you want to keep your message very simple, depending on who your client is, who's going to be listening to your statistical analysis. And so think about this as if you have let's say you're in a business and you're given a project to go do some research, marketing research, or cost production, or whatever, material research. And so you're giving this project to go off and research whether whatever thing is going to be profitable for your business. Is it going to make your business more money, or is it going to cost? Is it going to cut costs? Whatever. And then think about who your client is. It's your boss, right? Your boss. And you might ask your boss, what do you know about statistics? And your boss might say, I don't know anything about statistics. So just give me something I'll understand, right? So you think about what your boss needs. So go off and do a simple statistical analysis that will give a simple message to your boss to say, okay, from my research, looking at the averages or whatever, looking if we cut the cost in this different way, or rescheduling our workers with a different time schedule, whatever. From my research, it shows that we will make 5% more income, or we will cut costs by 5% if we do this. And it won't affect the total income of the business, but we can cut costs by 5%. That's, just give it to your boss and then let them make the decision. Just give the simple answer to the question. Don't make it complicated. Keep it simple. We can cut costs by 5%. And your boss might say, okay, show me what that looks like on paper. Okay, these are the costs of the business. We're going to lower them by 5% in these categories, but the production will stay the same, so that we won't change that. And then your boss will think, are there any other possible complications that we could have by making this change to cut costs by 5%? And you'll say, let me go research that to see if maybe there's going to be some sort of complication. And then you come back and say, according to my research shows that there is no confidence to say, yes, these complications are going to really impact the business. So basically you're saying, basically you would say at that point in time, from what I see through my research, these other complications are not going to be a factor. They're not going to be a significant factor in making this change. And then your boss says, great, that's exactly what I needed to know. Let's put this plan into action. Let's start cutting costs by 5%. And that way we'll make more money because we're cutting costs, right? So this is the way you want to use statistics. Find out what the important question is, but keep the message simple about what you're going to show. So thank you for your question, Dr. Masauso. I kind of turned it around to make my point here in the presentation that you want to keep things simple with statistics. Okay, this sample number 2. I think we got time for another sample. So now you're going to start seeing some of the more complex features in statistics. So somebody says that no more than 25% of students at AIU study more than 15 hours per week. Okay, so AIA claims that more than 25% of students study more than 15 hours per week. So you have this debate. Somebody says, nope, no more than 25% of students. So they're saying 25% or less of students study 15 hours per week. But AIU says, no, more than 25% of students study more than 15 hours per week. So somebody's going to say less than 25. We're going to say more than 25. Well, we can debate all day until we have an answer. And the only way to get the answer is to do statistics, find out, survey the students. So we surveyed 200 students, which shows 63 students studying more than 15 hours per week, right? So you basically ask the question, how many hours a week do you study? You ask 200 students that simple question. We could even do it during a Zoom meeting. How many hours a week do you study? Find out how many students answer, look at the answers, and we could do it really fast, but I don't think we have time right now. A quick statistical test. So is there enough evidence to support AIU's claim with the data collected? So we have the sample size 200. And the students who study more than 15 hours per week are 63. So the sample mean, which is this p hat, is equal to 63 divided by 200, which is 30.315. So basically that means that 31% of the students are studying more than 15 hours. So 31%. So the population mean is 0.25, right? This is what's being decided upon. This population mean is 0.25. That's what we're saying. Everybody's saying, okay, less than 25. We're saying more than 25. Okay, let's set that mean, that population mean at 25. Are we going to have more students studying or less students studying than that population mean of 25? And let's put a significance level in. This is that level of confidence, which is 5%, 0.05. Okay? These are some of the terms and concepts you use in statistics so that you understand where that population mean is that you're trying to test. Right now, we're trying to test this 25% level. So we'll make that our population mean. 50% more, 50% less. So where is it? We're trying to decide around this 25% population mean. Okay. Then we throw in this thing about a significance level of 0.05. Basically, that means you're going to have to be far enough away from the population mean to be confident that you have a different mean. Otherwise, we're just talking somewhere around 25% is the average that students are studying 15 hours a week. So if you get a number through your research that population mean is near 25%, there's really no way to figure out who's right. It's basically saying you could be right, I could be right. We don't really know because we haven't met that level of confidence to really show that either one of us is right. So you're setting the significance level at 5%. And if you look down here, right here in this graph, that's your level of significance. That's a significance level up there. So if you can come back with data to this side far enough away from that mean, okay, you've proven that you are correct. But if you get somewhere between here and here, there's 5% to either side, right? This side and this side. If you get your data results somewhere in here, you don't really, it's experimental error. You don't know if it's less, you don't know if it's less than or more than, because within here you could end up with any type of answer. So to really get a positive, conclusive, significant answer, someone needs to get the data to fall either out here, which is beyond this level of significance, showing that more students are studying more than 15 hours a week, or you need to get way down here in this area with your data to show that, no, I'm right. Less than 25% of the students are studying more than 15 hours a week. So these are the areas. If you land in here, one person is correct. If you land way out to the right, the other person is correct. If you land somewhere in the middle, you really don't know who is correct. There's not enough evidence to show that one person is right or one person is wrong. And that can be very important in so many, that can be very important in so many decisions that need to be made, is knowing really the strength of the data to show that one person is right or one person is wrong, or one material is better than another material. So ultimately you come to this hypothesis test. So the null hypothesis right here is basically saying H sub 0 colon P is less than or equal to 25. So that's the null hypothesis. That's what we're testing. We're saying that this mean that's going to come out of the data is going to be less than or equal to 25, somewhere in here. Less than, right? Less than somewhere out in this area, or equal to 25. 25%. The alternative hypothesis is going to say, wait, no. H1, P is greater than this 25%, it's 0.25. So you have the null hypothesis is basically the person saying less than 25% of the students study more than 15 hours a week. But then you'll have this alternative hypothesis to say, no, I think it's greater than 25%. And a one-tailed test is basically saying you just want to look to see if you can get the data out here into this area, out here. That's a one-tailed test. Two-tailed test would be that you want to find data in below or above. But right now we're just interested in this one section out here. We just want to know if we can refute, if we can say no, less than 25% is not right. We're going to do some data and show that it's more than 25%. But in order to show that, we need to get data, we need to get results far enough away from 25%. We just can't get 26%, right, in here, or 27%. It's still too close to 25%. There's this margin of error that we can't really say we're right and they're wrong yet. We need to get beyond this, all the way out to this 30. So the data comes in at 31.5, which is in this area. So that means we have shown with a significant value that they're wrong, and that AIU is saying no. From what we're seeing, 31% of the students study more than 15 hours a week. Okay, see how that works? All right. So let's go on here. Oops. Trying to figure out how to get out of there. Here we go. Okay. So basically, AIU claims that more than 25% of students study more than 15 hours per week. Is there enough evidence to support AIU's claim with the data collected? So you see how easy this is. You just ask 200 students, how many hours a week do you study? So here's the data from the sample. Sample size 200. Students who study more than 15 hours a week, 63. Sample mean was 31.5%. Population mean that we're testing is 25%, 0.25, with a significance level of 0.05, right? We got our hypothesis test and our alternative hypothesis right there ready to go. One-tail test. So using Excel, we compute the z-test value. This is a z-test. So you'll see the equation right there that you don't have to use. Excel does that automatically when you do its z-test through Excel. But it would be the p hat minus the p, which would be the mean that we're testing minus the result. Then the square root. So you see that. So it comes out to 2.12. That's the test of value. Don't worry about the test value yet. That's just a number that we're going to test. And then we want the p-value for 1.2 using the Excel function, normal point S, point distribution. So this is another function that you want to use. So we put in 2.12 comma true, and it comes back with 0.9830. We subtract 98.30 from 1. We get 0.0170. Since 0.0170 is less than alpha, which is the 0.05, we reject the null hypothesis. So you can see that once you understand these numbers, what that 2.12 is and the 0.9830, subtract it from 1 to get the 0.0170. Once you understand to get these numbers, you instantly know we have enough data. We have enough data that's significant here that is below that 5% threshold to show that students study more than 15 hours, that more than 25% of the students study more than 15 hours. So then, once you go through all that, and Excel actually does all those numbers instantly for you, you don't have to actually subtract 0.9830 from 1, because Excel, when you do the z-test, will actually just give you the 0.0170 as the significance result. And you'll know that that's less than 0.05, so you know your results are significant and important. So we write in our essay, therefore, AIU's claim that more than 25% of students study more than 15 hours per week is justified at the 0.05 level of significance, according to the data sample. And it's just that simple. You don't have to write much more than that. That's just explaining and interpreting the data results. Just that one sentence right there just summarized your data analysis. Then from there, go ahead and talk. Go ahead and keep explaining what you want to explain. To say, now that we know that more than 25% of the students study more than 15 hours per week, what does that tell us? What can we do with that information? How can I understand that? How does that change what I want to plan? What I want to talk about? What does that make me understand? How does that change my view about something? So just summarizing the results is just one sentence, but then it comes your opinions, your views, your analysis of that simple statement. So you can see how statistics go through some numbers. You ask 200 people how many hours a week they study. You put that data into Excel, and the data will instantly give you these numbers. And you'll know, okay, you'll know within a minute or two that, okay, AIU's claim that more than 25% of students study more than 15 hours per week is justified. So you write that up. So this is actually very fast, very simple. The ultimate message is simple. You solved the debate. With your research, you solved the debate. to say clearly, according to the data, more than 25% of the students study more than 15 hours a week. And that simply is very important to